All right, so let's talk a little bit about the implementing inheritance in object orientation versus implementing them in a database. Right? So in object orientation, inheritance is it's a very common concept, right? You declare perhaps a base class. Perhaps let's see, we can have a new class here in the models. We might employees. Let's say we have several employees, and there might be a base class employee, right? That might declare some of the things that are common across all employees, right? So you might have here a private string first name, private string last name, and private string social security number because we all pay taxes. So we can generate the setters and getters, whatnot, for this base class. Right, there we go. And then you might create several subclasses of this, based on certain aspects of different types of employees, where you might have maybe an hourly employee, or maybe you have a full-time employee, an hourly employee, a part-time employee, right? And they all have different ways of calculating different things. Maybe at the end of the week you need to calculate the paycheck for all of them, right? And they all get calculated differently, right? So here you might have a full-time employee, that has as a subclass, as a parent class, might have com.gga dot employee. There we go. So finish, and notice that it extends employee. That means that it has all the attributes of the base class employee, plus it can create its own, right? So we have typically it would make no sense to extend a class and then not have your own fields. It would just make no sense, right? If otherwise, full-time employees would be just an employee, right? There would be no any difference. So here you might have a float or double. You might have a yearly salary, perhaps, right? You might have yearly salary, right? And then you would have the setters and getters that go along with that. Okay. As opposed to maybe an hourly employee might have here hourly employee. Might have also as a superclass employee. There it is. Might have an hourly rate, right? How does that person get paid per hour, right? So that's going to be double hourly rate. So the question is how do you implement this when you're going to store this in a database? How do you implement it, right? Source getters, because databases don't support this abstraction of object-oriented. So how to do it? So there's there's three ways of implementing this in a relational database, right? And there's the denormalized implementation, which is basically you only have one table called the employee table, and the employee table has all the properties of all the classes, including the base class, plus all the properties from all the derived classes, right? So basically you would have one employee table with first name, last name, social security number, plus hourly rate, yearly rate, all of them, right? Plus an additional field called type, right, in the database. So that when you have any record, any particular record will be either an hourly employee or it will be a full-time employee, right? And but then the only way to distinguish, because since they're all in the same table, you can't know which one you are. You have to have this additional data type, right? This additional field that distinguishes one from the other. What type are you, right? If you are an hourly employee, then that means that the column for the yearly salary would be empty, would be null, right? And the only field that would make any sense would be the hourly rate. Yes? Okay. Plus the values for the base class, first name, last name. So all records have first, last, and social security number, but only hourly employees will have hourly rates, and only yearly a full-time employee will have a yearly salary. Make sense? Right? So that's the denormalized single table implementation. And I think that's what it's asking you. I forget. Is that what the assignment asks you to do? Single table? Okay. You also have the multi-table implementation. You have the normalized implementation. And there's two versions of it. Okay. One is the fully normalized one, where you have one class, one table per class. Okay. So let's take a look at this. See if MySQL Workbench wants to collaborate with me. So let's create a table here. So for the employee denormalized version, okay, so the single table implementation, you would have perhaps an ID, primary key, auto increment, say. You would have first name, you would have maybe last name, you would have yearly salary, double, we'll have here hourly salary, no, hourly rate, sorry. And this would be also double. Okay. Plus, you would have a type. Okay. So you have a type. Oftentimes it's called D type, right? Data type, or just type. And this would be a varchar, and the varchar would have to be from an enumerated data type, so that it would only the only possible values would be full-time or hourly, right? If I leave it as a varchar, I could inadvertently put any string in there, right? And that would break. We would want to avoid that. So that's one of the implementations. Now the varchar. So that's not a good idea to put a varchar. So what could we use there instead? So one of the requirements on the assignment is that you should not use the Enum feature of MySQL, and the reason is that Enum is not fully supported across all databases, right? So if you ever want to move your schema elsewhere, right, you're stuck with databases that support Enum. Right? Instead, what you want to do is implement it using what it's referred to as a portable Enum implementation. And I think there's a couple of slides on that in the presentations. But let's create an enumerated data type that we could use here, right? So let's do that. Let's create yet another table. And so this will be the employee type. Employee type, right? And so what it's going to do here is that it's going to be one field, and it's a type. It's the value. The value is going to hold the type. The value, it's going to be a varchar. It's going to be varchar, and it's going to be primary key, meaning there's no way that I can insert here two types that are the same, right? There has to be one value can be full-time, and the other value will be hourly. Those are the only valid values, right? And we're going to insert those values in here. It's not auto-incremented, And that's it. This type really doesn't matter what the name is. It's a common name for a column. But what we're going to do here is this employee is going to is going to have a foreign key to that employee type, right? So that the value for that foreign key can only be from that other table. That makes sense? All right, so first let's create this. Let's create this, apply. So it's going to just create the type, and we say apply there. Okay, very good. And now I should be able to insert in here the only two valid types, employee types. So we're going to say, not clipboard center, insert. So let's insert here. For type, we're going to insert full time. Oops. Okay, we're going to insert that. And we're going to insert another one. Oops. And the other one is, what was the other one? Hourly. Hourly. Ugh. Why isn't that? Can't type today. Hourly. So I'm going to say just full and hourly, right? So let's grab those two and execute that. So what's going on? Insert blah 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 error code duplicate entry 0 for key primary. What? For key primary. Was it int? What? Really? Didn't I choose varchar? Oh. Okay, let me drop that. I'm going to try that again. Drop table. Try it again. Oh, I have it here. So varchar. Let me try it again. Varchar. There we go. Apply. It says varchar, yes? No, I don't want to change the column. I want to create it. Employee type. This is varchar 45, apply. And it's a primary key. There we go. It is varchar. Excellent. Okay, let's insert again. Where are they? Okay, let's select that and run that again. Okay, so that seems to have worked. And now, when I create the employee table, where is it? Employee single table. There we go. This is going to be a varchar, but it's going to be a foreign key, right? So let's see. Where is my foreign keys? So D type, foreign key, D type. It's going to reference. Where is my D type here? My employee type. Why are you not referencing? Why are you not? It's not listing my. Why are you not listing it? Specify. Well, I don't know the name. Employee type, maybe? Oh, there it is. Excellent. And I want to say that it's referencing the type. There we go. Right? Foreign key, blah, blah, blah. Apply. Okay, let's review. So it's creating the table, employee single table, ID, first name, last name, okay, and the D type, where D type is referencing references is the employee type field. Yep, makes sense. We do an apply. There we go. So now if we insert here, create insert. We can create maybe for ID. I forget. Was an ID an integer? It was, no? Was it auto increment? It was, right? So I can remove it. So the first name will create maybe Alice or Ada, Lovelace, $200,000. So she's a full-time employee. So for the hourly rate, it'll be null, and for the D type, she's a full-time employee, so it's full. And I can't type anything other than full here, right? Or hourly, right? Right. Otherwise, it would. So basically, that D type is behaving as an enumerated data type, right? Without using the Enum. And we can insert maybe another one. We can say Bob Marley. He gets paid $200 an hour. No, wait, 200. And no full-time employee, so he's hourly. Was it hourly or hour? Hourly, yeah. Well, we would know, right? So let's run that. So that works, and so we can query that, and it still doesn't display. Did I hide it somewhere? I must have hidden the view. Panels, home. Ah! I didn't mean to do that. I must have hidden it, but without output time. What? I must have hidden the output somewhere. Anyway, that would insert it. Certainly, we can use JDBC to query it. So that makes sense with single implementation. So for multiple implementation, what you would do is that you would have one table per class. So let's do that. Let's play around with that. Am I not connected now? Oh, I'm still here. Okay, so let's do that. We would do we create a table. We would create the employee. So this is the full normalized, right? So this is the normalized. So normalized. And so this would look like we have ID. Primary key, it's auto increment, first name, we have last name, and we have social security number of the varchar, and that's it, right? We won't have the other ones. And then you would have here the other tables. This would be hourly, employee, normalized. You wouldn't actually call it normalized, right? I'm trying to distinguish between the two. So here, this also would be a primary an ID. So this would be a primary key, but it would also be a foreign key, right? And this would have hourly rate here, which would be double, right? And then the constraint here. It would be that, wait, did we create the other one? I don't see it here. Did we not create it? This single table. New table. You close that, don't save. That's type. Here, normalize. Oh, I never created it. Let me actually create it. Apply. So I think everything's good here. Maybe not. Hello? Ah! I think I lost connection. I know I crashed. Force quit. All right, never mind. I'll do it on the board. I'll do it on the board. Let me stop this.